All right, so question number 2, solve the equation by the zero factor property. Question number 2 is very similar to question number 1, so I'm going to go a little quicker through this problem. If you're looking for a more in-depth explanation, go ahead and take a look at question number 1, video number 1, and you'll find probably more explanation there. So we have the quadratic equation 3x squared minus 4x minus 7 equals 0. And just like we did with question number 1, let's go ahead and factor the left-hand side of this equation. And just like before, I'm going to go ahead and use the AC method. And the AC method tells us to take the coefficient of our leading term, in this case 3, and then we're going to multiply it by our constant, in this case 7, and that's going to give us 21. We want to now list all of the factors of 21, and hopefully we will see factors that will subtract, because this last sign is a minus, and we want factors of 21 that subtract to give us -4. Well, fortunately 21 only has 1 and 21 and 3 and 7, so shouldn't be too much of a challenge to find a list here that gives us -4, and I don't think we're going to be able to get -4 with a 1 and 21, but we can definitely get a -4 using a 3 and a 7. And if we want -4, I think we're going to have to make the 3 positive and the 7 negative, right? Positive 3 minus, remember we're using subtraction, minus 7 does indeed give us -4. And so I think we found a winner. And the AC method, all it does is it takes 3 terms, like we have here on the left, and allows us to rewrite these 3 terms as 4 terms so that we can then factor by grouping. And to do that, we'll go ahead and rewrite our first term. That hasn't changed. But what we are going to do is take the single term in the middle here, this -4x, and split it into 2 terms using a positive 3 and a -7. So we'll go ahead and say plus 3x minus 7x, and then -7 that was in the original equation equals 0. So we have 3x squared plus 3x minus 7x minus 7 equals 0, and that is equivalent, it's the same as the original quadratic we had, except instead of 3 terms on the left, we have 4. And now we can go ahead and factor the left-hand side of this equation using the grouping method. And I like to go ahead and isolate that middle sign, whatever it is, plus or minus, and what that does is it breaks the expression on the left-hand side of this equal sign into 2 parts. We have a left side and a right side. And if we take a look here at the left, we can go ahead and, looks like, factor out a 3x. And if we take out that 3x, we're going to be left with what? X plus 1, I think, right? And we can double check ourselves if we were to FOIL the 3x back into this binomial. 3x times x is indeed 3x squared, and 3x times positive 1 is 3x. So that looks good to me. And I'm going to go ahead and bring down the sign that we isolated, that minus sign. And now let's take a look here at the right-hand side, these 2 terms. What can we factor out here? Well, I'm going to take out, how about a 7? And if we take out a 7, we're going to be left with what inside? Well, let's see, -7 times x gives us the -7x that we originally had. And then -7 times positive 1 gives us this last constant here on the end, -7. So there we have it. And of course equals 0. And you'll recall from class that when you factor by grouping, what's inside these parentheses here has to match. If they don't match, you've done something wrong. Maybe here in the factoring process, or maybe it was somewhere earlier in your work listing your factors. You just have to go back and double check, make sure everything looks okay, because these factors inside the parentheses have to match when you factor by grouping. Well, they do, so we're on the right track, I think. And we'll go ahead and take the factor that's inside the parentheses, pull it down, and that'll go ahead and cancel out. And when we cancel out the factor in the parentheses, all we're left with is, what, a 3x and a -7. So that's going to become our second factor of our original quadratic. And so there we go. If we want to double check to make sure that we factored correctly, we could, of course, FOIL these binomials together, and we should wind back with what we started with, and indeed we do, but I'm not going to go through that process. And we're told to use the zero factor property, and so now that we have the two factors that make up the original trinomial, we can set each factor here independently to 0 and solve. So let's see. We have x plus 1 equals 0, and we'll have 3x minus 7 equals 0. And if we want to solve, of course, we could subtract 1 from both sides, and that'll leave us with x equals negative 1. And here we'll add 7 to both sides and divide by 3, and that'll leave us with x equals 7 over 3. So I'm claiming that those are our two solutions. So to verify, we would certainly want to check, especially on a test, to make sure that these two solutions do give us a true equality, a true statement when we plug them back in. Now in question 1 in the video, I manually plugged both of our solutions back into the original equation that we were given to verify the validity of our solutions. But because we're now in college algebra, let's go ahead and take advantage of some technology that we're now able to use that we weren't permitted to use earlier in our math series. And I'm going to go ahead and test the solutions here in our graphing calculator. And hopefully you have access to one. If you don't own one, try to get to the library as early as you can in the semester, because they do have a certain number that they allow students to check out for the semester. So go ahead and get to the library if you haven't already done so. But before we go ahead and discover whether or not our solution's down here, and I guess I'll move that over so we can go ahead and see what we are claiming the solutions to be. You want to go ahead and we want to make sure there is a specific setting that is preset. So on your calculator from the main screen here, go ahead and hit clear just to make sure we're good to go. And then I want you to hit the second button and then table set. And you should be given a screen that looks like this, the table set screen. I want you to then scroll down to the independent and dependent section. These are come into play when we are actually graphing and entering independent or dependent variable. And right now my calculator is saying that the independent is set to auto and the dependent is set to auto, but I want the independent to be set on ask. So I'm going to scroll over and hit enter on the ask, and now the calculator is saying, all right, the dependent variable, I will ask you to enter something, and the dependent variable I'll go ahead and figure out for you. And if this doesn't make sense, don't worry about it. I think it will make a little more sense here at the end when we test our solution. So just make sure that your table set looks like this. The independent is on ask and the dependent is on auto. All right, now we can go ahead and here at the top, go ahead and hit the y equals button, and you should come to the plot screen. And what we want to do is we want to enter the original quadratic that we had here on the left. So we want 3x squared minus 4x minus 7. And let's go ahead and hit graph, and let's just see. This should hopefully create some sort of parabola for us. And indeed it does. And what we want to do now is we want to tell the calculator to evaluate what the y value is at the specific values here for x. So at -1, we want the calculator to tell us what's the corresponding y value. We should expect it to be 0. And we want the calculator to evaluate what the y value is when x is 7/3. And again, we should expect that y value to be 0. So now that we've got our quadratic equation plotted here on the graph, you can go ahead and hit the second key and then table. And you should have a blank table. If not, that's okay. But what we can do is go ahead and now start entering x values. Notice that under the x column, you'll probably have a black input bar here. And what we're going to do is we're going to go ahead and hit -1. And when we hit enter, hopefully if we've done our math right here on the whiteboard, we should expect the calculator to output a 0. And let's see what happens. Oh, good, I'm glad. So what this is saying is that one of the solutions, if we're looking for a 0 for the y, then the x has to be -1. And this just confirms that at least this solution is correct. Now again, let's go ahead and input 7/3, and hopefully again when we hit enter, the output will be 0. The dependent variable will be 0. And indeed, it is. And so we know that, fortunately, when we were doing our math, everything worked out. And this is another way to confirm that our solutions, x equals -1 and x equals 7/3, are correct. If you don't have a graphing calculator, no big deal. We were able to manually find out whether or not our solutions were correct by just plugging them in and evaluating like we did in question number 1. But here we are, question number 2, the two solutions, x equals -1 and x equals 7/3.